All right, ladies and gentlemen, welcome back for another round. This is Mr. Doolin, and I thank you so much for tuning in today. Today what we're going to do is we're going to take a look at concentration and dilutions. And so a lot of times in chemistry, we'll be working with these aqueous solutions. So it's a mixture, right, where we've taken some amount of solid, dissolved it into water, and then we're going to use that and actually add it into our reactions in that way. And again, a lot of that comes down to just, man, I'll be honest with you up front, we don't really understand why yet, but let me just believe me now that when we add our reactants in an aqueous form, we actually can have those reactions occur a lot faster, and we'll understand why that occurs later on this year. But for now, just understand we do this a lot. And so understanding what concentration is and how we use it in chemistry and what dilutions are. So if we make a really concentrated stock solution, how do we dilute that down to something that's actually usable and functional for us are going to be really, really important, technical capabilities for us as we move along in chemistry. So first off, let's go ahead and do this real quick. Let's define exactly what concentration is for us. So our introductory definition of concentration is going to be, it's a measure of how much solute is in a volume of a solution. And believe it or not, in chemistry, this how much, a lot of the times what we're going to do is we're going to measure this in moles, and then this volume that we're dealing with the solution, we're actually going to measure that in liters of solution. And so immediately, as soon as you see this word moles pop up in this page, you automatically should refer back to it and say, all right, well, this means we're going to be able to do some stoichiometry with this. And a lot of times what we do in chemistry, we actually will change the definition of concentration, and we're going to refer to it as molarity, right? And molarity is really just the measure of how many moles of solute is in a liter of solution, right? And we see that in the definition in the formula of it, where we end up with molarity is equal to moles divided by liters, right? And a lot of what we're going to get out of this, ladies and gents, is this functionality that we can now start adding things like I referenced at the beginning, where we can start adding things in aqueous form. Right? And something I need you to understand as well, a lot of the times molarity will be abbreviated with a capital M, right? And so this formula here will a lot of times be written as moles divided by liters is equal to molarity. Now, and remember with moles, and I want to go back to this again, right? Remember with moles, we can get and convert to and from moles, like we can go grams to moles, and we can go backwards in there between moles back to grams. And so that's going to be really important for us in terms of like, hey, if I want to make a specific molarity of a solution, how many grams of that solid solute do I actually have to weigh out, right? And what we would do with this is, this becomes our working formula for molarity. And if we rearrange that, like we multiply liters off of both sides, we end up with a very important variant of this. And let me go ahead and switch my pen color here. We end up with molarity times liters is equal to the number of moles that are present. And so, again, with this one, a lot of the times what we're going to end up with is, hey, how many grams, right? Let me remember how to spell how. Let's put many grams of solute do I need to make a particular solution, right? And then with this one, a lot of the times what we're doing is, hey, if I took a certain amount of concentration, a certain molarity of a solution, and I added this many liters of it, how many moles did I just add to my reaction, right? And those are very important distinctions, ladies and gents, and I need y'all to understand that. I know I didn't write it down, but verbally I need you to understand when it would be appropriate to use one version of this equation versus the other, right? Because a lot of the times we're given a molarity and a volume and said, hey, we're going to put this in the reaction. And then to do stoichiometry with it, you would actually use this bottom equation and figure out the number of moles that we added. And then you could convert it to moles B and grams B and all the other things that you need to do, right? Okay, so now that we kind of are starting to understand how to calculate and make particular concentrations or molarities of solutions, we're going to introduce something called a stock solution. And I'm not going to write the definition here, but you need to get it down. And a stock solution is really just a really concentrated version of a solution, because you don't want to have to make a brand new solution every single time. A lot of the times when we deal with the solid form of the chemical, right, that's really, really concentrated versions of that particular chemical, and it's dangerous. So we don't want to deal with that all the time. So what we do is we actually make a concentrated stock solution, right? And so your stock solution, relative to your other solutions that we're talking about, your stock solution will always be the more concentrated, right? So again, a stock solution is just a very concentrated version of a solution that we're going to make. And then what we do with stock solutions is we actually will dilute them out, right? And again, the definition of a dilution that you need to understand is that we're going to just take part of a more concentrated solution and add more solvent to it to make a less concentrated solution. And let me go ahead and write that out for you. And so again, having it down here on the page, and you can read it, taking part of a stock solution and adding more solvent to it to make a less concentrated solution. And I need you to understand, like if we're sitting here and we've got a stock solution here, I literally mean we're going to take some of this out and we're going to put it into, let me make that beaker look right. And we're going to take it and we're going to put it into a brand new container, and then we're going to add more solvent to it, right? And so make sure that you understand the reference of dilution and what we're doing, right? We're making a brand new solution in a brand new container. And so the example I want to start you out with here is say that we take 5 liters of stock, right? And our stock is, let's say, 5 liters of a 1 molar stock solution. And then we're going to take that out, right? So this would be 5 liters. And then what we're going to do is we're going to add 3 liters of solvent to it. The question would be, right, because at this point we're really concerned about what the concentration of this new solution is. Well, this is why it becomes really important to understand that second equation that we had on our page a second ago. Because if I do 1 molar times 5 liters, what that's going to give me is actually 5 moles. And so what I did here is I actually took 5 moles out of my stock solution. I put it in a brand new container. And then all I'm going to do is I'm going to add 3 more. So now I've got, follow me here, right? This total new volume here is actually 8 liters. And so we have to start understanding at this point, all right, well, dang, if it's 8 liters, what's my new molarity? And so immediately I want you to understand, right, in this new solution, we only have 5 moles, right? And remember molarity times moles, right? And so I understand the second solution, the molarity of whatever it is times the volume, which in this case is 8 liters, has to equal 5 moles. And so you realize I can actually just divide this off, and I understand that this molarity here is actually going to be 0.625 molar, right? And so you get the idea here with dilutions, right? We take a specific number of moles out of our stock solution and we put it in a brand new solution, but with a different volume, with a higher volume, because we're adding more solvent. Now, this is a really big idea. I'm about to take this version, right? Because notice I have 2 things multiplied by each other equal to the same thing. So let's just go ahead and say, right, this was my molarity initially and my volume of stock that I added. And then this was my molarity afterwards, and this was my brand new total volume, right? And these 2 things were equal to each other, and what we end up with is our dilution formula, where molarity 1 times volume 1 is equal to molarity 2 times volume 2. And it's really important for you guys to understand what do each of those things mean, right? And so let's make sure, right, this is the molarity of the stock, and V1 would be the volume of stock used, M2 would be the molarity of that new solution that we're making, and then V2 is the volume of the new solution, right? And I want you to really, really kind of focus in on this, and we understand, right, V2 isn't the 3 liters, and that confuses people a lot, right? V2 is not how much solvent we added, it's what the total volume was. Right, and so I need you to understand, a lot of the times we'll need this, V2 minus V1, right? And V2 minus V1 will actually tell me how much solvent to actually dilute with, right? And so this becomes another, again, important version or part of of this dilution calculation. And so that's it, ladies and gents. Believe it or not, really quick, short, and sweet. But in this lecture, man, you learned how to calculate the molarity of a particular solution and really how to make that solution a specific molarity. And then when we make these concentrated stock solutions, how do we actually dilute them down into some usable, functional solution that we can add to a reaction, right? So there's really two equations here. And I guess let me go ahead and just clear the board here and say our two equations are molarity is equal to moles divided by liters, and then the dilution calculation of M1V1 is equal to M2V2. And these are the two main formulas that we learned today, and hopefully you'll get some practice today and be able to function and wrap your head around how you're going to see them and how we're going to use them and how we use them in everyday life, to be honest with you. And so that's it, ladies and gents. If you have any questions, I'll see you in class or I'll see you in tutorials.